everyone. So today we will now hear in general education, mathematics, and the topic is plain geometry. So good everyone. Before we begin our lesson, let me ask you first. Have you ever noticed the shapes around you? Think about the windows in your house, the screen on your phones, or even the tiles on the floor. Why do these objects have specific shapes? Why are some rectangle while others are square or even slanted? Now, let's take a step further. Imagine you are a city planner. You need to design a park with pathway, benches, and playground. So you want to create spaces where people can walk freely, can walk comfortable, sit, and play. But how do you decide the shapes of these spaces? What angles should you use to make sure everything fits together perfectly? Or, yeah, so this is where plane geometry comes in. Geometry is all around us, helping architects design buildings, engineers construct bridges, and artists create patterns. So it helps us understand shapes, angles, and their properties, which are essential in many real life situations. Today, we will explore angles, how they are measured and classified, and the properties of the quadrilateral, such as rectangle, square, rhombus, trapezoid, and parallelogram. So, by the end of this lesson, you will see how geometry is not just about numbers and lines, but also about the world we lived in. Let's define what is a geometry. See, geometry is a branch of mathematics that deals with the flat shapes and two-dimensional figures that exist on the plane. So unlike solid geometry, which deals with three-dimensional shapes like cube and cylinder, plane geometry focuses on the shapes we have, but only the length and width, but no depth. Okay, let's move to the basic elements of the plane geometry. The first one is the line. So a line is a straight one-dimensional figure that extends infinitely in the both direction. So about the point. So the point is the fundamental element in geometry. It represents a location in space that is no width or size and depth. So a point is usually labeled with a capital letter A, B, and C. It is drawn as a small dot on a plane. Even though a point has no dimensional, it helps define shapes and position. So example of the points in real life is the tip, excuse me, the tip of your pencil touching the paper and the end of the ruler. Now, the plane. So a plane is a flat two-dimensional surface that extend infinitely in all direction. So a plane is labeled using a single uppercase letter, plane M. So it has length and no width, but no thickness. It has length and width, but no thickness. So a plane is made up of an infinite number of points and lines. So any three non-linear points or points that do not lie on the same straight line define a plane. So, for example of plane in a real life is the surface of the table and the whiteboard or the chalkboard that in the classroom. Now, let's us move on into the angle. So, what is angle? Angle is a form when two rays met at a common endpoint, so called the vertex. Think of it like opening a book. When the book is closed, there is no angle. But as you open it, an angle forms between the two covers. So here are the types of angles: right angle, acute angle, straight angle, and reflex angle. First, right angle. So right angle is formed as a perfect square corner like the edges of a book or a building. We usually see a small square, as you see there in the screen. There is a small square in the corner of the right angle to indicate its measurement. So, for example of the right angle, the corner of the books or your notebook, a square or a rectangle table. Now, acute angle. So acute angle is an angle that measures less than 90. So right angle is 90 degree, while a- acute angle is less than 90 degree. So think of a slice of a pizza or the hand of a clock at 10:10. So that is an example of an acute angle. So think of also a paper fold slightly. When your paper is fold slightly, that is a acute angle. Now let's move on to the obtuse angle. So obtuse angle is any angle that measures greater than 90 but less than 80. So obtuse is greater than 90. When we say right angle, it is 90 degree. Acute angle is less than 90 and obtuse angle is greater than 90 but not less than 180 degree. So, it looks like an angle that is wider or more open than a right angle. For example, the wing of a butterfly when slightly spread, or the hand of a clock at 10:15. So where's the 10? Here. 10, 10:15. Okay, now let's move on to the straight angle. A straight angle is exactly 180 degree. So exactly 180 degree. That is what we call straight angle. So it looks like a completely straight line, as if the two rays are pointing in opposite direction. For example, the hands of a clock at 6, it's straight line. A balance scale when perfectly level. That is an example of a straight line. Okay, now reflex angle. So a reflex angle measures more than 180. So straight line is 180. Now reflex is more than 180 but less than 360. So it looks like an outside portion of an acute or obtuse angle. For example, a door opened too wide, almost closing it one step. That is an example of a reflex angle. Or a swing at a playground moving backward. That is also an example of a reflex angle. Okay, so how many angles do we have? We have five. angles. So the first one is a right angle. Right angle is 90 degree. Acute angle is less than 90 degree. Obtuse angle is 90 degree but not less than, more than 90 degree but not less than, but less than, I mean 180 degree. Here in straight line is exactly 180 degree, and reflex angle is 180 degree but less than 360 degree. Okay, polygons. So polygon is close shape with three or more sizes. Now take a look at this one. Triangle has three sides, right? Triangle has a three sides. Square has three sides. Pentagon has square has four sides. Pentagon has five sides. Hexagon has six sides, and heptagon have seven sides. So here is the formula in getting the numbers of diagonal. For example, in a triangle, the formula is n times n minus 3 equals to I over 2. So there are, how many sides are there in a triangle? 3. So 3 minus 3, since we are going to minus the number inside the parentheses, so 3 minus 3 equals to 0. Okay, now we will multiply. 3 times 0 equals 0. So it means that there is no diagonals in a triangle. So how about quadrilateral? So there are, I mean square. So in square, there are two of four numbers of four sides and two diagonal numbers. In pentagon, there are five sides. So a pentagon have five diagonals connecting different non-adjacent vertices. So for example, a star symbols contains several diagonals. Now, let's move on to the types of quadrilaterals. Here, this is the parallelogram, the rectangle, the square, rhombus, trapezoid, and the kite. But let me ask you a question first. Have you ever looked at the tiles on the floor, the windows of your house, or the screen on your mobile phone? What do they have in common? Yes, very good. They all have four sizes and four corners. These are example of quadrilaterals, a very important type of shape in geometry. So today we will be discussing the different types of property of quadrilateral, the different types of quadrilateral and their characteristics. Now look at this time. A rectangle. So every angle is a right angle and opposite side of a parallelogram of an equal length. So a rectangle is a parallelogram with four right angles or 90-degree each each sides. So the opposite sides are equal and parallel. So for example, the doors and the window. That is an example of a rectangle. Now, square. A square is also a right angle, 90 degree. So a square is a special type of rectangle where all sides are equal. So here, all angles are 90 degree and all sides are equal. So diagonals are equal and perpendicular. For example, the rubric cube face or the chessboard tiles. Question: can a square also be called a rectangle? Why or why not? Yes, it's because it is four right angles, but it is a special rectangle where all sides are equal. Now, rhombus. So, rhombus is a parallelogram where all sides are equal, but the angles are not necessarily 90 degree. So, as you can see in the screen, in the picture, it is slightly slanted. So, it is not um, um, necessary 90 degrees. So, it is a for example of this is the diamond-shaped road sign or the kites. This is an example of rhombus. So, how is a rhombus differ from a square? So, a square has right angles, but a rhombus may not have. So, that is why. Now, let's move on to the parallelogram. So a parallelogram is a quadrilateral where opposite sides are parallel and equal in the length. For example, in the parallelogram, laddered view from the side or the shape of a handbag. No, what I mean is that is not a parallelogram, sorry. What I mean is a slanted books in the shelf. So that is an example of a parallelogram. So now let's go to the trapezoid. So what is a trapezoid? It is a quadrilateral with at least one pair of parallel side. So for example of this is one pair opposite side. What I mean is example of this is the shape of the handbag. As you can see the handbag, so it looks like this. It looks like this. So it's like a handbag. So question, why is a trapezoid not a parallelogram? It's because a parallelogram has two pairs of a parallel side, but trapezoid has only one. That is why a trapezoid is not a parallelogram. The last one, kite. A kite is a quadrilateral where two pairs of adjacent sides are equal. So, as you can see, you know what is kite, right? So, that is an example of kite. So, like decorative paper craft, that is an example of kite. Now, let's move to the area. So, area, class, have you ever, or classmates, have you ever wondered how many space your, the classroom, the classroom, or how much wrapping paper you need to cover a book? So, here, this is what we call the area. So, area is the amount of space inside a shape. It is measured in the square units like squared centimeter, squared meter, or squared inches. Now, let's move on to the area of a rectangle. So a rectangle has opposite sides that are equal and four right angles. So the formula of getting a rectangle is area is equal to length times width. For example, a classroom is 8 meter long and 6 meter wide. So since the length is 8, so 8 times 6, since the width is 6, equals to 48 square meter. Number 2, a square. So a square has all four sides equal and four right angles. So in getting the square, here is the formula. Side by side times side is equal to side. For example, a square tile has sides length of 5 cm. So find its area. So 5 times 5 is equal to 25 squared centimeter. Now, a parallelogram. So a parallelogram has opposite sides equal and parallel. So its angles are not necessarily 90 degrees. So in getting the parallelogram, formula of this is base times height. For example, the parallelogram has base of 10 centimeter and height of 4 centimeter. So, area is equal to 10 times 4 is equal to 40 centimeter. Now, a rhombus. A rhombus has all sides equal, but its angles are not necessarily right angles. So, in getting the rhombus is equal to 1 half times diagonal 1 times diagonal 2. For example, the rhombus has diagonal 12 cm and 8 cm long. So, in getting this one, 1 half times 12 is equal to 6. 6 times 8 is equal to 48 centimeter. So the answer is 48 centimeter. Now, the trapezoid. So a trapezoid is only one pair of opposite sides parallel. So the formula of this is 1 half times a plus b times h. So, for example, a trapezoid has bases 10 centimeter and 6 cm with a height of 5 cm. So, here, look at the solution. 1 half times 10 plus 6 is equal times 5. So 16, 12 times 16 is equal to 6. No, 1 half of 16 is equal to, I, 1 half times 16 is equal to 9, and 9 times 5 is equal to 40 a squared centimeter. Now the last one is the kite. So a kite is two pairs of adjacent equal sides. So the area of this is 1 half times diagonal 1 times diagonal 2. So look at that example. So 1 half times 9 times 6 is equal to 27 squared centimeter. Now let's answer this one. How many diagonal does a pentagon have? So how do we find the diagonals? So we have formula, right? That d is equal to n times n minus 3 times 2 times 2 is equal to I over 2. So since pentagon has, since pentagon has 5 sides, so we will solve it is 5 times 5 minus 3 times 2. So 5 times, so 5 minus 3 is equal to 2. So 5 times 2 is equal to 10. So our diagonals is equal to 5 since there is an over. So the answer is letter this one. How many degrees are in the right angle? So is it A, B, C, or D? So in A, what is it called? 30 degree. It is an acute angle. How about 60 degree? This is still an acute angle. How about 180 degree? This is an example of obtuse angle. So the right angle is 90 degrees. Now, okay, so throughout our lesson on plane geometry, we have explored different geometric concepts, right? From angles under type to properties of quadrilaterals under area. So we started by understanding angles, their measures, and how they form the building blocks of geometry. When we examine polygons, particularly quadrilaterals, and how their unique property defines the classification, whether as a rectangle, square, parallelogram, or rhombus, trapezoid, or kite. So finally, we'll learn how to calculate the area of each quadrilateral using specific formula in helping us measure the safe space they cover. So, geometry is not just about shape, it's about how we see and measure the world around us. So, by understanding their properties and measurements, we can make accurate design, solve real world problems, and sharpen our mathematical thinking. So, I will leave this message. The world is made up of shapes. When you understand them, you understand the structure of everything around you. So, so the next time you look at the window, a book, or even a soccer field, remember you are looking at geometry in action. So that's all, and thank